Problem 512. So in this problem, we have a uniformly charged metal shell that is rotating with an angular velocity omega. The problem also gives us the hint, use the results of example 5.6 to calculate the magnetic field at the center of the uniformly charged spherical shell. So looking at example 5.6, we can see that from the way they've defined theta, it might be helpful to define theta on our shell as being the angle from the equator. So at the equator, theta is equal to 0. At the two poles, at the top pole and the bottom pole, theta is equal to 90 degrees, or pi over 2 radians. Now, to find the piece of current, we can use equation 5.23 on page 220. The K variable, current per unit width, with a surface charge density sigma and velocity v is K is equal to sigma times v. Well, sigma we can say is the total charge divided by the total surface area, Q over 4 pi r squared. And v is the linear velocity of a piece of that strip. Now, since this sphere is rotating at a constant angular rate omega, we can say that v is equal to r times omega, but different r, not necessarily this r. If you think about it, the points at the equator are moving faster, the points at the poles are moving 0. So our effective radius, that is how far our particular strip is from the equator, is actually r times cosine of theta. So the formula for surface charge, for surface current density is Q over 4 pi r squared, that's a sigma, times omega r cosine theta, that's the speed, and it's in the phi hat direction. We're going to ignore that, but that is the direction that it's traveling. Next, we're going to look at example 5.6. Example 5.6 tells us the magnetic field at the center from a ring of charge, or from a ring of current. Well, this tells us how the current is distributed over the surface. If we take just one small strip of it with angular width d theta, and therefore linear width r d theta, we can say that the small amount of current carried in that strip is equal to k times that width, so k r d theta. We already had k is given by this, so we multiplied by r right there, and d theta. And so that is the small bit of current in that particular ring. And this is a function of theta, and because we have done this, we started with rings of constant angular width, we can go ahead and integrate this with respect to theta to get our current. Now, another result from example 5.6 is that, and I'm going to look at the first answer, B is equal to mu naught I over 4 pi. So dB is mu naught di over 4 pi times cosine theta over, they called it script r, but what they're using for script r is analogous to our big R, times 2 pi, and then what they're using as big R is what we're finding analogous to big R cosine theta. Now di was given by this term right here. So this is going to take a little bit of algebra. So so this is mu naught carried from here. I'm going to take this 2 pi over 4 pi and just going to make it over 2. There's cosine here, so cosine squared. And r in the numerator, r squared in the denominator over r. So this is basically every part of this except for di. Then I'm going to go ahead and take this term for di, plug it right into here. And lastly, I am going to simplify things. There's this mu naught to here, q and omega from here. Cosine squared times cosine becomes cosine cubed. And 2r times 4 pi becomes 8 pi r. So dB is equal to mu sub naught q omega over 8 pi r times cosine cubed of theta d theta. Now, because of the way that I divided this sphere into strips with constant angular width, I only need to integrate d theta. And all of these terms are not dependent on theta. So it just becomes an integral of cosine cubed theta d theta. Now our bounds of integration, if you remember how we defined theta, theta is equal to 0 on the equator. So it goes from negative pi over 2 on the bottom to positive pi over 2 on top. Negative pi over 2 to positive pi over 2. And the integral of cosine cubed theta d theta is 4/3 from these bounds. So this times 4/3 gives a magnetic field, and keep in mind this is the magnetic field at the center of the sphere. Anywhere else we would need to do this whole mess again. But it is equal to mu naught q omega over 6 pi r.